Good morning, good afternoon, good evening, ladies and gentlemen, wherever you are around this world. My name is Bill Rivers, and welcome back to Tracerco Talks. Today, once again, I have another exciting guest, Mr. Stuart Brown. Stuart is a business development manager for Europe and Africa for Reservoir. Welcome to the show, Stuart. How are you doing today?
Thank you, Bill. Thank you. Very good. Thank you, sir. Very good.
Before we get rolling down this track and we get into the meat of what we're going to talk about today, give the audience a little bit of background about yourself. Tell us a little bit of something about yourself.
Well, Bill, I've been in the industry for coming up for 30 years now, and I started my career in the sort of the surface part of it. So, where we started getting involved in like the drilling, cementing side, and then I moved into production enhancement and into fracking, acidizing, and then a few years later I moved into coiled tubing, hydraulic workover, and modular drilling. And then eventually I started with Tracerco about 10 years ago now. So now I'm involved in the reservoir. So it started from pretty much the surface and it's worked its way down into the reservoir, into the deeper echelons of the interesting engineering and the reservoir technical side. So that's where I am now with Tracerco Reservoir.
So you mentioned reservoir. When I think of reservoir, is that like is it considered the same thing as like on land where you're drilling for a reservoir of oil or gas? Is that the same type of deal? But you're looking at an offshore concept?
Essentially, you could be offshore or onshore. I use the word reservoir as a sort of overarching terminology we use within Tracerco, and the reservoir department encapsulates a number of different services within that group. So, for example, if we stick with the reservoir terminology, we would offer a service called interwell tracing, where we inject tracers into an injector, and we follow that to a producer and monitor for sampling at the producer side and look for those samples that come through. So that injector may feed one producer, it may feed two or three producers. And the point is that a unique tracer is added to each injector with the intent of looking at the expected recipients, i.e. the producers further down the line. And that could be over a number of days, weeks, months, even years, depending on the size of the reservoir field. To give you an example of another part of the services we offer within reservoir would be on the fracturing side. So we add tracers to a fracture where we are pumping, or another company is pumping proppant or even acid, and we add our tracers to the mix as it's injected into each stage, each frac stage. And by means of sampling as well, they're able to determine which of those zones are producing. And that's pretty much the essence of fracking, is where you basically take all the samples back at surface and you analyze for unique tracers arriving back at surface in that sample from each particular zone, depending if it's flowing or not. And we can look at oil, gas, and water, all three phases. Into our reservoir side, we are looking at predominantly water tracing or even gas flooding tracing. And then lastly, the other main topic within the reservoir department would be on what we call inflow. So inflow is predominantly geared also for new wells where new completion is being run in the ground, and within that lower completion, whether it happens to be a particular type of completion string, screens, sand screens, wire wrap screens, whatever they happen to be, premium mesh, we design our tracers to fit within those compartments, within those areas of each zone of interest, whatever the customer happens to be interested in. Whether it be the heel, the mid, the toe of the well, or indeed if there's multiple zones, 5, 6, 7, 10, 12, 20 zones, whatever it happens to be, we can put unique tracers into each of those zones. And during the flow back of the production, oil and water can be monitored. Thanks to the unique tracers, they are 100% dedicated to each of these phases. And again, back to the sampling, which is the key to the process. You're looking for tracers within the samples that you're taking. And the beauty of this type of technology isn't just a simple qualification where it's a yes or no. And that's fine if that's what the customer wants. That's something that we can easily provide. What we also can do is take it to a deeper level and offer a quantification. So interpret what the data is telling us and then report that back to customer in a more detailed fashion so that they understand the journey the well is taking from day one when production starts all the way through to either several weeks, months and beyond, depending on what their ultimate goals are and the objectives of their project. And then the beauty, of course, of that is that the data is turned into information, and that's the whole process here. Is the key to the success of the operation.
See, to me, what you just described seems incredibly complicated. I won't lie to you. It just seems like there's a lot of integral parts, a lot of things moving around. Um, One question I did have for you. So you mentioned unique tracers. So what is a unique tracer? I mean, what is that about? So you're basically saying tracers are all not the same. So there's different types of tracers, I guess, for different types of applications. Is that what you're saying?
Yeah, essentially each tracer that we use it has to be unique so that you can differentiate between each zone. That's key. It has to be inert. It has to be safe. We don't want it interacting with anything downhole to the point that it's going to cause confusion. So there has to be a perfectly logical and robust process of selection that would occur in the laboratory during the finding out process before a tracer gets anywhere near a customer's well. So we must have a strong, resilient set of tracers that are able to operate in very challenging conditions. As I mentioned, the phases. So we have tracers specifically for oil, for gas, for water, and each of these are 100% dedicated to their cause, so that again it doesn't cause confusion between phases. The tracers we currently use and have done for a number of years now are based on organic chemistry. We don't use radioactive tracers. We tend to operate within the boundaries of the organic chemical side, which is much safer. And I guess it's easier to ship around. It's predictable in the sense we understand our tracers from the analysis methods that we use. And that's also important. It isn't just tracers reacting downhole or not reacting downhole and behaving the way we wanted. We have to be able to analyze for them. So these tracers need to go through a method, through what we use, gas chromatography, mass spectrometers, in our laboratory, analytical laboratory, where we analyze for these tracers so that we understand that these actually are the tracers that we're looking for and not some other background information. And that's why they have to be a very specific type of tracer to basically cover all of those angles and also survive downhole for as long as the project requires them to be.
So how many different tracers do you have? I know you mentioned the three different phases, and you said they're all unique tracers. So do you know how many types of tracers you have for different types of applications?
In total, we have hundreds of different species.
Oh, wow.
Sometimes they can interact in different services, so you could mix and match interwell inflow and fracking together. Not all in the same operation, but I mean is that some of these tracers will cover all of those bases. Some of those tracers will operate in each of those conditions. For example, with gas tracing, we've around ability to offer 19 gas tracers. We're going to have well over 30, 40 oil tracers and more oil tracers again on top, water tracers again on top of that, much and such the same. With fracking, we would offer more like 40, 50, 60 plus tracers for that service, because some of the type of fracks that's occurring in the shales, you have lots and lots of fracks. You need lots and lots of tracers. So there's a very large amount of species available overall. However, what we need to be careful of is when we're offering these services to our customer that we don't confuse where there might be an inflow and an interwell job happening. We don't want to use the same tracers. So that will limit the tracer count, but it means that you have them specifically put them into each camp to alleviate any chance of confusion. But if you round them all up together, yes, there's this a couple of hundred different species. It's a large amount of tracers that we have in our artillery, so to speak.
So this is very customizable. So when you're talking to a customer and you're interacting with a customer, it's more of a very customizable result, I guess. Maybe that's not results, not the right term you want to use, but you sit down with the customer, you talk to him about it. The process is very customized based on what his needs are. Does that sound about right?
Yes, I suppose what you would call it is a tunable tracer. You can tune the tracer. So, for example, in inflow tracing, where you're looking for maybe a number of years of lifetime. So the customer might say, like, I want to analyze this well for the next 3 years. I want you to take samples, and I want you to tell us, how the well's behaving from start to finish. So to do that, you need to look at the temperature of the well, you need to look at the well conditions, the flow. And once you have those understood, you would then pick a tracer that could behave in that well zone very, very well, confidently, and of course give you the lifetime that you're looking for. And when I call it tunable tracer, we would create a recipe that would involve the making of these tracers, putting into basically a solid plastic-like piece that gets inserted into the completion string. And that is based on a specific recipe that's designed for a specific temperature. So there's quite a number of variables that we must receive from the customer, not just the objectives, but also the well data. And then we convert that information to help us produce the correct recipe, as it were, for that particular tracer. It's a little simpler with the fracking side and the interwell side, where you're not so much tuning the tracer, you're still picking the tracer based on the conditions that you need to operate within. However, you tend to just find that, do you need an acid tracer for an acidizing frac? Do you need a particular oil, gas, or water tracer for your fracking? And that tends to be a simpler process based on the fact that the tracers can operate within that conditions. Then fine, you're good to go. Interwell, similar. You have to have tracers that can operate within the particular well conditions. So if it's a very high temperature reservoir, you'll err on the side of caution and go with a specific set of tracers that operate in a higher temperature environment. So it is kind of tuning per job, and each job will require its own dedicated technical overview and analysis and understanding before you even get to the operational side. Whereas, as I say, the inflow side is quite tunable in the sense that you're actually building a recipe of ingredients to create this end material suitable for the customer's well needs.
You know what, Stuart? I'll be honest with you. I found my new word of the day: tunable. I love it. I'm gonna start using that in my conversation. I love that
Excellent.
word.
Excellent. Tune
So,
tracer. There you go.
so how is all this? You talked about the different types of tracers. You talked about the different types of reservoirs. What goes into them. But how do you actually get, I guess, the tracers into these reservoirs and into these wells? Is it a special process? Is it just a straight chemical dump? How does that work?
Yeah, that's a fair question. It's a good question, Bill. I mean, the processes are going to be individually different because of the nature of the operation that you're working within. So if we take the interwell tracer, where we are dealing with injectors and producers through the field, we take our tracer. So it's going to be in an IBC container. So it might be 1,000 litres, it might be a few thousand litres, depending on the size of that particular reservoir. And our liquid tracer is injected along with the water flood or the gas flood. And what we like to do is dose the tracer in over a period of time, not slug it in, but dose it in over a period of where they may be pumping at 5 litres per minute. And this tracer is then distributed throughout that water flood, and then throughout the reservoir, and then it ends up, the water flood front ends up in the production the producers. So that's where we can analyze for. So that's how those go in as a liquid format. The frac tracing is always also liquid, and what we do with that is we end up putting liquid tracer into the proppant or into the acid. So it goes in at the deepest tip for the hydrocarbon side, so oil and gas. And that makes sure that oil or gas tracer goes into the fracture as deep as possible and makes contact with that hydrocarbon. The key here is contact. You want the tracer to make contact with the target fluid, because that's what activates it. That's what makes it do its job. It isn't interested in another phase. It wants to do the phase that it's attracted to. And then we add tracer across the whole water phase in the frac, so that we can then understand cleanup. We monitor for how well the well's cleaning up, what sort of tracer we're getting back from the water phase to ensure that frac zone is cleaned up and then starts producing the hydrocarbon. The inflow is quite different. Again, we talked about the tunable tracer. It was being a little different to the other ones because we're making a recipe. Well, that recipe is important because we're creating what would look to, in layman's terms, plastic rods, plastic pieces, bars or strips, depending on the type of completion, where would we insert them or place them into the completion. So it has to fit within an area of real estate that gives us enough space to put our tracers in. During the manufacturing phase one of the major screen companies, we would be involved with that part where we can put our tracers in. And these plastic rods or bars or whatever they happen to be come in a specific set of sizes. They fit within the appropriate OD of the screen. So whether it's a 5.5 inch, 65/8, 7 inch, we would appropriately use the amount of tracers accordingly. And the tune tracer, to keep using that terminology, would then become part ensconced within that screen. And that then becomes a holistic final piece of the puzzle. So when that lower completion is then shipped to the well site, it looks, for all intents and purposes, exactly like any lower completion that would have arrived at any other point, because our traces are already inside. So there's no critical path time lost with having to do anything on site. The unit is ready to run as a lower completion. And the pipe tally is then calculated with the stenciling that's on the side, which tracer it is then correlated with the pipe tally to say, right, we want this tracer here. We then move up the well a bit and we put this tracer there, and so on and so forth as they move through the well. And that way, the customer then knows exactly which tracer is in each zone, and they can then make a judgment call as to which tracer is coming from which zone, and how much of it, importantly as well, when they want to quantify and understand the upside of the well. Is it producing too much water? Is it producing good oil? In fact, is that zone no longer working? Is it no longer flowing? So these are the kind of important decisions and judgment calls they can make based on the tracer data as it comes back to surface from our sampling technique.
So I know you touched on this a little bit, but you said about sampling. So how do you gather all these samples? Where do you gather them from?
Well, again, the tracing principle is the same throughout all the services. And this is where it gets a little easier to, I guess, to understand. You could just say, well, what I'm trying to do here is get a physical well sample. So anywhere where a tracer has traveled from point A to point B, whether that is through the reservoir or through the well bore, whatever it happens to be, the sample that comes back is key. It's a relatively simple process in terms of the physical attributes of what you're trying to achieve, but it's such an important part of the puzzle. And the sample count is really important when you're trying to quantify, because I always like to use the analogy of televisions. And in the old days where you may not have an HD television, you had more pixels, a lot of visible pixels, I should say. The greater the pixel count, so once you get into full HD and then 4K, and of course, indeed 8K, you're talking about billions of pixels, but they're tiny, tiny pixels. But the point is the picture is clearer. So the more pixels you have, the more detailed picture you're going to get. And it's a similar principle with samples. The more samples you have, up to a certain point, of course, then the more data you have and the more detail you can apply to your interpretation. So it's really important to look at the samples as a key deliverable. And that's one bit you don't want to forget about operationally when the customer perhaps is being reliant upon to take the customers they have to take the samples. It's important for them to realize it's a key piece of the puzzle. We also recommend sending our team to do it, because we want a dedicated set of people taking these samples. So when they take the sample, and it might be one a day, it might be one a week, one every couple of weeks, or indeed it might be one every 5 minutes, depending on the objectives. You've got to make sure that you're taking the sample from the right well. Of course, that's key. You've got to label it. You have to make sure you write down the time of it when the sample was taken. And you don't necessarily have to analyze every single sample, maybe 1 in 5, 1 in 4, because you're just looking for the tracer, and you're always going to find it because it might not have arrived yet. And the tracer's not going to lie; it's either there or it isn't. And that's why you need to keep searching. So you might discard those samples and keep trying until you find the tracer. And the samples tend to be oil samples in an aluminium bottle, proper shippable bottles for safety reasons. Plastic bottle for water samples. Obviously, gas can be done in a number of ways, a couple of different ways, whether it's the absorption tubes, catch tubes as we call them, or indeed if it's through gas cylinders. You've got to think about the shipping of these. We don't need a huge amount of chemical tracer sampled. From the production fluids, we could maybe get by with, say, 50 milliliters of a sample. We typically take more, so we have a repeatability in the analytical lab in case you want to do the test again. But in terms of actual amount. We only need about 50 milliliters of water, maybe 20 milliliters of oil sample. So we're talking very, very small amounts, and which makes it easier to handle and ship. But the key is the timing, when you took them, and then to ensure that they're labeled and securely sent without any contamination back to our laboratory, where that happens to be around the world. We have several laboratories fixed around the world. And then that's where the magic starts to happen. This is the clever piece, is the data analysis, where the guys get involved using GCMS machines. Whatever preparation that's required for those samples takes place in the lab, and they get put in the machine, and within a few days, the customer can start to see the initial data come back, and then our technical team will take that data and they'll turn that into information. And that information is where we really start to give the customer a good heads up on what's happening with their well, and they can make really good decisions based on that data.
So you're essentially a critical part of the process of like recovery of the oil, recovery of the gas. This what you offer is essentially very critical, because it actually offers key, I guess, quantifiable data for a customer to make a really good decision on the viability of that well.
Yes, absolutely correct. It is key to possibly some of their future decisions. They may not be able to do a lot about something at that particular point in time, and it may be the next well that they're focusing on, thinking, okay, how do we drill the next well? Do we drill it as deep? Do we drill it shallower? Because the tool isn't producing as well as we thought. Or indeed, if they have a smart well, or they have ICVs that they can operate, then perhaps they may shut down a zone completely because it's watered in too much. And that water is causing issues with production. So if they can shut that zone in, that's worth a lot of money. There's a real value created with the ability to shift that valve, shut that water in, and focus on the really good zones that are producing the hydrocarbon, which is the key to this. And of course, sometimes it might be in a frac situation, they'll have expensive equipment waiting with other companies to make a decision where they need to rig down. They can't make that decision until they know that they have a full flow from the plugs, throughout the plugs through the tool back to surface. And once they know that, once the tracer gives them that positive ID that is good to go, the company can instruct the service company to rig down their equipment, and they don't have to perform, for example, a coiled tubing clean out, and they can move on and save some money that way. Because as you know, standby time, it can get expensive as well if you're hanging around waiting for a result. So the key for us is to get the information back to the customer very, very quickly. And certainly with oil analysis, we can provide on-site analysis very quickly, perhaps within 1 or 2 hours with the equipment at site. Water is going to take a little longer because you have to prepare the sample for the analytical phase, and that takes a bit longer. It takes a bit more effort to do that. But when you're looking for the hydrocarbon coming back, you can give that very, very quick instruction back to the customer that you're good to go. You have flow from the tool back to surface, and they're very happy to be able to move on with their project, because time is money.
Well, Stuart, I won't lie. This has been a very fascinating conversation. It really has. I have learned a lot today. I mean, we're about ready to wrap things up. Is there anything else you like to, as your parting comments or anything you like to add?
I just anything, if anyone has any questions, about the technology, or wants to get into more case studies, or even some SPE papers that's been written about tracers, that'd like to get some information on that, then please reach out to me and let me know, because I think that's where you're going to see the benefit, is what other customers have benefited from. And we always like to show a good story that the tracers have kind of saved the day, but being realistic about it, the customers are going to possibly be blindsided if they don't have this data. And what we tend to find is, once the engineers, the departments that love this data, once they have it, they want to keep getting it. They want to have a repeat of the next well with the data of the tracers. There has been customers in the past that have told me that they've been working in their field for like 60 years, and they say, we still don't understand what's going on, and tracers can really help them to understand that and deliver a real positive result to their fields. The net production values, what they're looking to achieve, and also please the management to say, hey, we really understand what's going on now. We can build models and use tracer data to enhance our reservoir models. Or indeed, like I mentioned about the coiled tubing clean out, there's been times where production looked good, in the first, say, 7 days. And because the tracer can continue giving data over a number of weeks, that that information changes. You look at the production profiles over a matter of days. It may not change hugely. You look at over a 2-week, 3-week, 4-week process, and you can see a huge difference between daily production from each zone. And there'll be times where you might go away after you've run, let's say, a PLT tool, and it'll give you a snapshot in time. But that's only a snapshot at that particular moment in time. Tracers are giving you a story, a video. They're giving you like a real time basis, basically, of what each day is telling you. And as a result of that, you might find that your zones that you thought were good are no longer producing. And with that in mind, the customer could then make a judgment call, bringing in, let's say, coil tubing cleanup to jet out the zone that they thought was actually good because it looked good to start with. And that's the key here, is that it's a developing story, and you don't hang your hat on the data that you initially see. You can actually monitor what's going on over a longer period of time. And I think that's really important, because the well does not behave exactly the same day in, day out. There are subtle changes, and that's the beauty of the tracers. It gives you a great story to tell.
That's great. Well, Stuart, I think we're about out of time here. I'd like to thank our guest today, Mr. Stuart Brown, Business Development Manager for Reservoir for Europe and Africa. If you'd like to get in touch with Stuart, his email address is stuart.brown@tracerco.com. You can also follow him on LinkedIn. As always, reach out to our website at www.tracerco.com, or you can also follow myself on LinkedIn. With that, thank you again, Stuart. Ladies and gentlemen, have a great day.